In this question, we've got a picture representing a balloon B above the ground, which is along KM. And we've got Katie and Mona looking up at this balloon. Katie sees the balloon at an angle of elevation 52 degrees. Mona sees the balloon at an angle of elevation of 34 degrees. They measure 350 meters between them. They're trying to work out the height of the balloon. So we need a strategy. Height of the balloon above the ground would be this length. There's Mona. 34 degrees. Now the only way we're going to be able to work out the length BN, the height in this right-angled triangle, is if we know another length in this triangle. And we're going to concentrate on side BM, because if we look at the whole triangle, this side BM we can find, because we've enough information. We've got 52 degrees, we've got 34 degrees, and we've got 350 meters for this side. Two angles, then side in between them, we should be able to use the sine rule to find BM. So we'll find BM, and then we'll go to this triangle once we've found that, and we'll use, well, how would you describe it? SQA. It's a right angled triangle. It's a simpler problem. But this big triangle BKM is not a right angled triangle, so we'll have to use, in this case it's going to be the sine rule to find out BM. So let's do that. In triangle BMK, now remember the way we work this is that the side opposite angle M, for instance, is little m. The side opposite angle K would have length little k, and the side opposite angle B would have length little b. Now we're not interested in that one. We're interested in this side K, length K and length B, and we know these two angles. Now the sine rule in this triangle, remember, it's the length of a side divided by the sine of the angle opposite it. So K divided by sine 52 degrees would be equal to little b divided by the sine of, oh dear, we don't have that angle B. Well, how do we work out angle B? Well, we know the three angles in this triangle add up to 180. So angle B would be what's left after we subtract the sum of the other two angles from it, 52 and 34. In other words, it's 180 minus 86. So that's 94. You could do that on your calculators. But 94 degrees. And remember, we're trying to find K on its own. We would get rid of this divide by sine 52 by multiplying both sides of this equation by the sine of 52. So K would equal, and if you're multiplying a fraction by a number, it'll appear on the top. So it's B times the sine of 52 degrees over sine of 94 degrees. And we do know what little b is, it's 350. So the calculation we do is 350 times the sine of 52 degrees over the sine of 94 degrees. And that gets us this side BM. So let's do that. Grab our calculator and make sure you're working in degree mode, otherwise the signs will not work out correctly. So 350 times sine of 52 divided by sine of 94. And that all comes to 276.47 and so on. So we know that. We'll keep that on our calculator, we might use it in a minute. So in triangle BNM, you have to make sure that you have a diagram of what we mean by BNM. So we've dropped a perpendicular from the balloon to the ground, and we know that was 34 degrees. We've already worked this out. It's 276.47 and so on, and we're trying to find BN. Well, knowing this angle, the opposite and the hypotenuse, that involves the sine. So the sine of 34 degrees is opposite BN over hypotenuse, which we know is 276.47 and so on. And remember, we're trying to get BN on its own. We get rid of this divide by 276.47 by multiplying by 276.47, and have to do that on both sides. So 276.47 multiplied on the left, and the same number multiplying on the right will get rid of this divide by 276.47. So we'll just be left with BN on its own. So that's the calculation that we have to do now. Let's drag out the calculator again. So it's this number, 276.47 and so on, multiplied by whatever the sine of 34 is, sine 34. That comes to 154.60 and so on. So the height of the balloon is, now does it ask us for accuracy here? Calculate the height of the hot air balloon above the ground. No, it doesn't usually, therefore it's three significant figures. That'd be 155. It's nearer 155 than it is to 154. So it's 155 metres, and that's to three sig figures, or to the nearest metre. To the nearest metre. That's Mr. Corsi signing out. Hope you enjoyed the video.